A chemical reaction takes place among three molecular ions that have each lost 2 electrons, two molecular ions that have each gained 4 electrons, and one molecular ion that has gained 2 electrons. The products of the reaction are 2 neutral molecules and multiple molecular ions that each have a charge of magnitude E. And the question is wanting us to figure out how many molecular ions are produced if all of them carry the charge of the same sign. So either all negative or all positive. And it also wants us to figure out whether they are all negative or all positive. So the first thing that I did here was essentially just draw a sketch of kind of what this reaction looks like. So you can see we have three molecular ions have each lost 2 electrons, which anytime you lose electrons, you're getting a net positive because you have more protons than electrons. And then we have 2 molecular ions that have each gained 4 electrons, which opposite logic there. If you've gained 4 electrons, that means you have 4 more negatively charged. You have gained a negative 4 charge essentially on that ion. And then finally you have the 1 molecular ion that has gained 2 electrons. And same case with those in the negative 4, just that in that case only 2 electrons were gained. And then the product is 2 neutral molecules, which essentially just means equal number of protons and electrons, and 4, or we don't actually know yet, but some amount of charged particles at the end. And I have them as E there because the problem indicates that each one has a charge of magnitude E. So moving on with this setup, we'll be able to solve. So the first thing that we want to do is actually just add up all of the net charge at the beginning, which is using that idea that we learned in this chapter that charge is going to be conserved. So you can see that when you add up all those charges, you get a net charge of negative 4, which we can also write as 4e, since E just indicates an electron, essentially. So with that in mind, we were able to solve that in addition to those 2 neutral molecules, we're going to have 4 negatively charged ions produced. So yeah, that is the solution to this problem. I think one of the trickier parts, honestly, is in the setup, because sometimes when you're reading these really wordy problems where it says each lost 2 electrons, you can get confused and make things positive or negative when they shouldn't be. So for this type of problem, really reading it carefully. Also just remembering this concept that charge is going to be conserved at the beginning and end. So yeah, that's pretty much it. Thank you for listening.